Okay, welcome to Bangladesh. It's not Dhaka, it's Taka, 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 Taka. You go way back in the roof of your mouth. Taka, 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 Taka. Okay. So we're doing light. It's understanding light. We're going to look at the nature of light. Okay. So what does it say in Getting Ready? Fauzia, what does it say?
How is the light from a light bulb similar to the light?
All right, you got to go slowly and loudly so we can hear you.
Loudly.
Loudly.
How is the light from a light bulb similar to the light from the sun?
Yeah. How is a light bulb similar to the sun in terms of light? Okay. Excellent. Okay. What else?
Why do you have to stand directly in front of the bathroom mirror to see your face?
Why do you need to stand directly in front of a mirror to see your face? Excellent question. What else?
Why do objects look different when they are immersed in water?
Why do things look different when they're immersed in water? Excellent. I like that. All right. Now, what about key ideas? What do we got?
Okay, how various sources produce light?
What? Say that again?
How various sources produce
How various sources produce light. Excellent.
two basic properties of visible light.
Basic properties of visible light. Excellent.
How to use the laws of reflection to describe the behavior of light.
Laws of reflection and how to describe the behavior of light. Excellent. What about key skills? Was that the last one?
Oh,
We got more under that? Okay, I'm sorry, key ideas. Yes, carry on.
what happens to light when it strikes different types of surface?
What happens to light when it strikes different types of surfaces? I like that. What else?
How transparent objects can change the path of light.
Say it again.
How transparent objects can change the path of light.
How transparent objects can change the path of light. All right. What else?
Key skills.
Key skills. Okay, we're on skills now. Go on.
Use a protractor to measure angles of reflection and refraction.
So we're going to use protractors to measure angles. Okay. What is it?
Reflection and refraction.
To use a protractor to measure reflection and refraction. Okay.
Calculate the cost efficiency of lighting.
The what?
Calculate the cost efficiency of lighting.
Okay. Write this down. I want you to go on the internet, not now, over the weekend, and bring in a printed copy. You have printers at home. Printed copy of an electric bill from North America or Europe. A printed electric bill. Yeah. A printed electric bill. Okay. Can you do that?
Yeah.
Okay. Good. What's next?
Analyze experimental results using diagrams.
All right, so we're going to use diagrams, and we're going to do experiments, and we're going to summarize the results of experiments using diagrams, right? Okay, what else?
Design your own investigation of refraction.
All right, we're going to design our own experiment. That's heavy-duty stuff. All right, now your chemistry background is probably you've probably done a little chemistry, right?
Yes.
Now, what does that have to do with light? Well, I'm going to tell you, okay? I'm going to tell you where light comes from. Light actually comes from the atom.
What?
You know? Yeah, light comes from atoms. You know? I know, weird. And I'm going to keep this very basic. But how many people have ever heard of the word atom? Yes? How many people have ever heard of the word nucleus? Okay. How many have ever heard of the concept that the electrons orbit the nucleus?
What?
The electrons orbit the nucleus. Does that make sense? Do you ever heard of the word electron?
Yeah.
Do you know that electrons orbit the nucleus?
Yeah.
Yeah, they go around the nucleus. Okay. So here's the nucleus, and here are electrons, right? Going around the nucleus. Is that okay? Yeah. And what they do is, they travel at different levels around the nucleus. Now, the closer the electron orbits to the nucleus, we'll put these in letters. Can we do that?
Yeah.
We'll say this is K, L, M, N. That's actually the old designation of the levels, believe it or not. This is an old style. This is called the Bohr diagram, the Bohr representation, Niels Bohr. All right. So the farther from the nucleus, the less stable the electron's going to be. The closer to the nucleus, the more stable it's going to be. Now, when we say stable, that's big. When we say stable, do you know what that's code for? When you say stable in terms of electrons, you mean low energy. When you say stable, you mean low energy, right? Yes? So, I have two electrons, let's say. I have an electron here, and an electron here, okay? This is going to be A, this is going to be B. What electron has greater stability, A or B?
A.
A has greater stability.
Because it's near.
Excellent. What is it?
Because it's near to.
It's near the nucleus. What electron has lower energy?
B. Because it's.
No, listen to me. Stable, low energy, right? Which one is more stable, A or B?
B. Oh.
Which one is more stable, A or B? What is it? A is more stable. It's closer to the nucleus, remember? The closer you are to the nucleus, the more stable. Therefore, which electron has lower energy? A or B?
A.
A has lower energy. Make sense? Right? Okay. Now, 1. Do you think the electron, do you think that the atom is extremely well organized? It is. It's extremely well organized. Do you think that everything that happens in the atom, do you think that it's predictable? Do you think it's so organized that it's very predictable? It's very organized, and it is. It's extremely organized. Everything is predictable. The way it is, you don't like it, I don't care, that's just the way it is. Okay? Now, if I take an enormous amount of energy, just a giant energy gun. Giant, what is this? You're kidding, right? You're trying to trip me? You want me dead? Okay. Giant energy gun, right? And I'm going to bombard this with enormous amounts of energy. What's going to happen to the electrons? I'm going to put so much energy into here. What's going to happen to the electrons? They're going to jump to higher levels, right? Why? Logic, remember?
More energy.
Yeah, more energy, so the electrons will be farther away from the nucleus. But you know what happens right away? It's amazing. The electrons will jump and then they'll jump back. They'll jump and then they'll jump back, right? Yeah? And so here's what happens. I take an atom, right? And it goes to this level, right? And then it goes back down. What's it going to give off? It's going to give off the energy that made it jump to here. Well, how much energy did it absorb to get there? It didn't absorb all this. It absorbed a very little amount of it, didn't it? It absorbed a very little amount. And only amount that it absorbed, it's going to give off. It's going to give it off. Simple. I know it looks really hard, but it's really very simple. Okay? Listen, let me review it. Stable. High stability. Low energy, right? The closer you are to the nucleus, the more stable. High stability, low energy, right? If it absorbs energy, it jumps to a higher orbit, and then jumps right back down. Clear? Yes? It's going to give off energy. That's it. You don't have to know anything else about it. Okay? That's all I'm going to do. Okay? You know what this is called? You know what this is called? This energy? It's called this. And it's going to be in the book. It's going to be called electromagnetic radiation. Do you know what that's called? You know what another name for electromagnetic radiation is? You don't know? Let's see if this makes sense. Let's see if this makes sense. It's called light.
Oh.
That's what light is. Light comes from this electron transition emissions. How do you spell emission? Electron transition emissions. That's where light comes from. You get it? Yes? That's where light comes from. Now, you get it? That's light. Yes or no? Okay. All right. All right, I'll put it on pause and we'll go back, but you can read what you got. But that's where light comes from. It comes from electron transitions, and then emissions. Understood? It's called electromagnetic radiation. Electromagnetic radiation. And that's where light comes from. Yes? Okay, good.